I will not tell you that monads are like burritos or something. Instead, we will go through a specific error handling example and see how they emerge naturally. Say you are writing a tool that determines the median value of all values written in a single line text file formatted like this. It should process the following steps. Take the path to a text file as command line argument, read the text file, parse the content, and calculate the median. They are not difficult to implement, but they all can fail at runtime. From the error handling lecture, we know that the maybe type is useful for such cases. So let's use it to define our function declarations. Sadly, we cannot simply compose these functions since the types do not match. The inner details of these functions are not important here, but to have some code that we can test with, I quickly implement them. getInputFilePath simply checks for the correct number of command line arguments and returns just a string if everything is okay and nothing otherwise. readFile returns nothing if the file cannot be read and just a string with the content of the file if it is okay. It also removes unneeded whitespace characters on its way. ParseContent does something similar to what you saw in the programming challenges in earlier lectures. It splits the content on a separator and parses the tokens. But this one here returns nothing if one or more of the tokens cannot be parsed. CalcMedian only works on non-empty sequences, while showMedian just formats our output. Okay, now we need to get a feeling on how we can work with them. I will now write out the whole chain. Oh my, that is a really ugly pyramid of doom. But wait, can you see the pattern? Every level looks like the following. Wouldn't it be great if we could factor out this control flow? Let's just dream what it could look like in a perfect world. Perhaps something like this? This magical and then function would do all the checking work for us. Just from the code above we can deduce that its type must be the following. So it takes two parameters, a function taking a normal value and returning a maybe, and a maybe value with an inner type that could be fed into the function. In case the second parameter is a just, it should apply the given function to it and return the result. If the second parameter already is a nothing, the result should again be a nothing. It turns out that it is very easy to implement. Isn't this cool? We just made our code a lot shorter and much more readable. Imagine how the original version would have looked like with not 3 but 10 chained function calls. Horrible! Oh, and by the way, while we were just making our code better, we developed the core functionality of the maybe monad. F+ of course also provides and then for maybes with the name and then maybe. This version even deduces the return type, so one does not have to name it explicitly like here. The function and then is called bind in other languages. In Haskell it is written as an infix operator that looks like this. This is also where Haskell has its logo from. Oh, let's see if our code compiles. It does! But wait, what is going on here actually? Scott Vlashin from fsharp4funandprofit.com uses the term railway-oriented programming for the control flow pattern we just used. He gave me his permission to borrow his great analogy to give you more visual intuition for what happens in our consecutive calls of and then. We come in from the left with our value and hit a function, say read file. It can let us continue with a new value wrapped in a just, or send us down to the nothing track. If you now have two such functions and want to compose them, it simply does not fit, because the numbers of tracks doesn't match. This is where and then comes into play. It provides the necessary plumbing to compose these two parts. After having passed the function f, we still drive from the left to the right, but now on one of the two parallel railroad tracks. And then makes sure that if we are on the nothing track, we will stay there. But if we are on the just track, we hit the next function, which can decide as before if we continue on the just track or if it will send us down to the nothing track. I hope the type signature of and then now looks a lot more intuitive. If we want to get rid of the temporary variables in our code, we can even compose functions and then style. This is called Kleisli composition and has the following type for composing two functions. Using its version with 4 arguments, we can shorten our code to this. But the basic concept is still the same as with and then, just in point-free notation. There are a few laws a monad, just like the one we just developed, should obey. For example, composition should be associative. In our case, it is not needed to know all of them, because we fulfill them anyway. But if you want to dive deeper into this and read about totally different monad instances, I recommend reading Learn You a Haskell for Great Good, which is available online for free. It also describes why every monad is a functor as well. Since we already know that maybe is also a functor, this is quite clear for our example. So, after all this talking, let's actually run the code we just wrote. Oh, we need to provide the file name, of course. Yikes! Something went wrong, but what is it? The file probably does not exist, so let's create it. Okay, it works, but not knowing what went wrong in the case of an error is everything but a smooth user experience. Do we now have to go back to exceptions to be able to provide error strings to make the failures more clear? But our code is so beautiful now, we do not want to go back. But what can we do? The nothing part of our maybe type is so empty. Instead, we could attach an error string to it in case something went wrong. This type is called result. F+ provides this class too. It can hold either an OK value, which is like the just value in our maybe, or it can hold an error of a certain type. Strings seem natural here, but it is possible to use any arbitrary type for the errors. The result type supports the same monadic behavior as maybe, that is and then and Kleisli composition. Here is a great exercise for you to let the concept of monads really sink in. Rewrite our command line tool using result instead of maybe, so it provides meaningful error messages to the user in case of failure. Implement the and then part of the result monad on your own. Your function template declaration could look like this.